All right, here is the next question. So here we need to find the gradient vector of the given function at a given point. Right, so how do we do that? Uh, Basically, it's very simple. So we just need to find three partial derivatives. Right? So if this is our function, I don't know, f of x, y, z, then the gradient f is just, uh, you know, the vector fx, fy, fz. So we've got to just differentiate with respect to x, y, and z, and then substitute the given points 0, 0, and pi over 6. I guess we could, when we differentiate with respect to x, we could actually substitute the given values of y and z first, and then differentiate with respect to x. But since all the three partial derivatives are involved, and just to avoid confusion, I think it's easier to differentiate in the general form, like find f x, then fy, and then f z in the general form. Okay, so partial derivative of f with respect to x is what? E to the x plus y times cosine z. So we've got to differentiate the exponential function. It's just e to the x plus y. Well, times the derivative of the exponent, but it's just one. So cosine z with respect to x is a constant. So nothing here. Plus that there is y plus 1. Well, that there is sine inverse x. I personally prefer writing it as arc sine, just to avoid confusion with the reciprocal with 1 over sine x. So this superscript -1 doesn't mean they taking the reciprocal. So it's not the power, it's not the exponent, it's rather the inverse function, right? So okay, so y plus 1 divided by the derivative of the inverse sine is square root of 1 minus x square, and that's it. Okay, so let me do all the three of them first, and then I'm going to substitute 0, 0, and pi over 6 as x, y, z respectively. So the next one is fy, e to the x plus y. The exponential function, its derivative is the same. Then the derivative of e to the x plus y with respect to y is just 1. So nothing here. Cosine z is a constant. Plus y plus 1, its derivative is, I guess, it's just 1 times inverse sine. And again, I prefer writing it as arc sine x. And then f z. All right, so e to the x plus y is just a constant now. The derivative of cosine is minus sine, so minus sine z, and there is no z in the second term, so that's it. Okay, so now we are going to substitute 0 for x, 0 for y, and pi over 6 as z. Okay, so then fx e to the 0 is basically 1 times cosine of pi over 6 plus 1 divided by square root 1. All right, so this is just 1 plus cosine of pi over 6 plus 1. So what is cosine of pi over 6, right? So how can we figure it out? All right, so what is cosine of pi over 6? So let me write it here. So pi over 6. Now pi is 180 degrees, so pi over 6 is actually 30 degrees. So we need to sort of draw this triangle. If this is 30 degrees, this is 60 degrees. Right. So basically, if this is 1, then what are the other two sides? So this should be 1/2, and this should be, I guess, from the Pythagorean theorem, is square root 3 over 2. All right. So which tells us that cosine of pi over 6 or 30 degrees is actually uh, square root 3 over 2. And well, while we are on the matter, sine of pi over 6 or 30 degrees is sine of pi over 6 is 1 half. Okay, so what we get here is square root 3 over 2 plus 1. All right, now Fy. So e to the 0 is still 1, cosine of pi over 6 is still square root 3 over 2, plus arc sine of 0. All right, so what is this? So this is the angle whose sine is 0, but we know the sine of 0 is 0, so it's just 0. Okay, so we actually should just have square root 3 over 2. Okay, and finally, this one here, fz is e to the x plus y is still 1. Sine z, as I already computed, sine of pi over 6 is 1 half. So this is negative 1 half. Right, so the answer is, it's just the kind of, since it's the nebula f, it's the gradient vector, so we've got to, combine them together into a single vector. So square root 3 over 2 plus 1, square root 3 over 2, and then 1 over 2. So that's the answer.